That is graphing sine functions. So you see here, there's a little example sine function, but there's some pieces to this that you may not be familiar with, so let's go through those pieces. So, some vocab before we get to graphing. Now, there's a lot to write down here, so if you need to, make sure you just pause the video, get all these things written down. You need all these in your notes. Okay? So, first piece of vocab, amplitude, denoted by the variable a. The amplitude of a sine function is half the distance between the minimum and maximum y values. So, if your maximum y is, say, 40, and your minimum y is 8, you find the distance between them, and you find that by subtraction. So 40 minus 8 equals 32, and you take half of that. So half of 32 would be 16. So 16 is the amplitude. Okay, it's half the distance between the minimum and the maximum. So you do maximum minus the minimum, cut that in half, you got your amplitude. Next little vocab is known as the equilibrium line. This is a dashed horizontal line that travels through the middle of our graphs. If you add the amplitude to the equilibrium, you'll get to the maximum. If you subtract the amplitude from the equilibrium, you'll get the minimum. Now you know where the equilibrium line is because it's always equal to the constant number that's at the end. So see, at the end of this sine function here, we've got a plus 8. What that means is that our equilibrium line is at y equals 8. If this was a minus 7, it would be y equals negative 7. If there was nothing here, our equilibrium line would be at y equals 0. Last piece of vocab, probably what you're going to spend most of the math work of this graphing doing, is known as the period of the function. The period of a function is the total distance one cycle of the graph covers. Now we say one cycle because sine functions, much like cosine functions, repeat themselves. So if you're to zoom out, the graph looks like it's just repeating itself over and over and over and over again. Now, instead of dealing with the entire length, we just care about one cycle. So that's the total distance of one cycle, which is the period. Now, the period of a function is found using this little formula right here, 2 pi divided by b. Now, what is b? The variable b is the coefficient that's attached to the x. So see, in this example function, okay, it's not the 6, it's not the minus 10, it's the 4, because the 4 is the coefficient that's attached to the x. So to find the period of the function, we take the b value, which is this number right here, this 4, 2 pi divided by b, which would be 2 pi over 4, which reduces down to pi over 2. Now this is very important right here. Leave the period as a fraction, just like we did when we were converting to radians. Okay, leave the period as a fraction. It actually makes the work easier. So bringing it all together with our vocab. Amplitude is the variable a. He's always hanging out front. This is our amplitude, whatever number's here. The period is found with the b variable. He's the guy inside here with the x. C is the constant that's used for the equilibrium line, and it's a dashed horizontal line that goes through the middle of our graph, and we use it to find our maximums and our minimums. The shape of a sine graph. All sine graphs have one of two basic shapes. All sine graphs will look like either the positive or the negative. Obviously, if it's positive, it's going to look like the positive. If it's negative, it's going to look like the negative. Regardless, all sine functions, all sine graphs have 5 major points. So all positive sine graphs will look like this. The first point is on the equilibrium line. It goes up to the maximum, back to the equilibrium line, down to the minimum, back to the equilibrium line. Now it's important, these aren't sharp edges, this is a curve. So we draw a little curve through there. Let's try that again. There we go. A little curve through there, little curve through there, and that's our graph. Okay, 5 points. 1, 2, 3, 4, 5. Negative sine functions start the same, starts at the equilibrium line, but since he's negative, it goes down to the minimum first, then back up to the line, back up to the max, back down to the line. So it has this little look. Let's try that again. There we go. Okay, you notice they look pretty much the same. It's just positive goes up first and then down, negative goes down first and then up. But they all have those 5 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The 3 points on the equilibrium, and then they each have a point at the max and a point at the min. It's just when those happen that's different. All right. Now, how do we graph given all of that? It's actually a lot easier than it seems at first, but let's break it apart. So the first thing that goes on your graph is the equilibrium line. That's the very first thing that goes on the graph. This guy right here. So our equilibrium line is at y equals 5. Okay, why 5? Because that's the number here. So all of our graphs are going to look like this. We got a solid vertical line because that's our y-axis. And this dashed this dashed horizontal line, that's our equilibrium line. So at the very end here, we're going to put y equals 5. Because that is our equation for the equilibrium line. Now, let's get our maximums and minimums. Now, to find that, all we have to do is we add the amplitude, which is 2, to the equilibrium. So, what's 5 plus 2? We get 7. Right? We added 2 to 5, and we get 7. Our minimum y, we subtract. So 5 minus 2 equals 3. So the bottom of my graph here, sitting at 3. So we added 2 to get to the top, minus 2 to get to the bottom, right? 5 plus 2 is 7, 5 minus 2 is 3. Now this next step is probably the hardest part of it all, and it all starts with the period of the function. Okay? Now the period of the function is always found with sine this little formula, 2 pi over b. Our b value is the guy that's hanging out with the x. So 2 pi divided by 4 would reduce down to pi over 2. Okay, now what does that tell us? This is the end of our graph, which means that this is our last x value. So the last x on our dashed line here is pi over 2. Now, what about our other x values? To find them, it's actually a pretty straightforward thing. You take the period and you multiply it by 1/4. right? We're going to divide this line into 4 equal pieces. So to do that, we times the period by 1/4. Doing so, we'll divide this into 4 equal chunks. See? 1, 2, 3, 4. So we take our period, which was pi over 2, times 1/4. Pi and 1 would be pi, 2 and 4 would be 8. So we get pi over 8. This is the scale of our x's. Now, if you remember back in algebra, what that means is these little hash marks are counting by pi over 8s. So this is 1 pi over 8, 2 pi over 8, 3 pi over 8. Now this guy would be 4 pi over 8. Well, what is 4 pi over 8 reduced down to? Pi over 2. So this is what we are counting by on our x-axis, whatever the period times 1/4 is. So now we got everything we need. Got everything we need. Now this guy is positive, so he's going to match this positive shape. So point on the line, we go up to the maximum, down to the line again, down to the minimum, back to the line. And then as best we can, we draw a little curve. And we have our graph.